Yeah, I'm sorry. I didn't mean to be hounding y'all, but Blackboard's just always so confusing on how they have it separated out so that I would have one grade at the, toward the end of the semester, and then come entering all the grades, it's completely different than what it was shown.
Yeah. I think the only thing that you guys were able to see was like a homework and quiz average. Like the tests, you didn't get to see those averaged in. I think that was the issue, but it should be fixed now. Yeah, so you can actually, and like, I don't know visually how it looks to you, but it's at the very end of the list as I see it, because it was the last thing I put in there.
So we'll be able to see what our grade is so far in the class, is what you're saying.
What's that?
We'll be able to see our overall grade thus far in the class.
You should be. And if anybody wants to kind of check that while we're just doing this stuff, and let me know.
I went in and looked, and it's been updated.
All right, good.
Yeah, I can see mine too.
Cool. All right. We probably should have had that up there like a while ago. And I know Richard had been asking about it, and I was like, yeah, I'm sure it's there. Ended up that it wasn't. So anyway, everybody, you can check your averages then and see how you're doing. Anything else?
Yeah.
I think we're good.
Okay. So
Unless
I start on this. So let me change my view. Ooh. That is horrible. So let me fix that a little bit. Does that make it better?
just looks a little smoggy.
It's like, better, worse? Probably about the same, huh?
Yeah, it's looking pretty good.
Okay, so the first thing we're doing is a quick quiz, 1 through 10. I think I get 3 on there. Let me look at the list. Javier, do you want to do 1 and 2? TJ, you want to do 3 and 4? Sabrina, you want to look at 5 and 6? Romeo, 7 and 8? Richard, 9 and 10?
Got it.
Maybe I can get them all. If I zoom out a little bit, then they're not going to be legible, probably, huh?
It looks okay. I mean, it's not clear, but I think you can figure out what words are.
Okay. So is Javier around? Yeah, down here. All right. Okay, so 1 and 2. So I know 1's not on your list, but we're doing it anyway, because why not? Graphs of normal distributions. So it says A always looks exactly the same, B always have the same characteristic bell shape, or C can have any shape as long as they have a sharp central peak. And so this is talking about just like things with the sort of normal sort of curve. They're not specifically talking about the standard normal. They're just talking about the general sort of normal thing. And if we're talking about the normal thing, which one of those would it be?
For question 1?
Yeah, for question
Are you
1.
just asking anybody?
I was asking Javier. If
I
he's
think
around.
it's B.
B. So they
Yeah.
always have the same
Yeah.
characteristic bell shape. So talking about like why these other two don't work. It's not always the exact same shape. It can be a little steeper. It can be a little less steep, or a little less or a little more varied, right? And so your standard deviation can be different, and so it can be more or less varied. And so that's why A doesn't work. C, no, there's a lot of things with sharp central peaks that are not uniform, right? They don't have that uniform shape. They're not symmetric. So that's not the only thing. That wouldn't define it by itself. And so I guess move on to part 2. Says in a normal distribution, the mean is equal to the median, is greater than the median, or can be greater or less than the median. And so this was also Javier.
Is equal to the median, A.
Yeah, it's exactly equal to the median. If it's symmetric, we get that the two things are equal to each other. And so we're talking about skewness. One of them is going to be greater than the other if you have things that are skewed, but if they're normal, they're symmetric, which means they're equal to each other. Part 3, who is that, TJ?
Yeah.
Okay. So in a normal distribution, data values farther from the mean are less common than data values close to the mean, more common than data values close to the mean, equally as common as data values close to the mean. Ooh.
I put A, less common than data values close to the mean.
Yeah, and if we look at the shape, like the curve is going down, right, as we go further from the mean. And if it's going down, that means there's less of those entries. So where are we at? 3A is what you said? Yeah, that's it.
Yes, A.
4, consider wages at a fast food restaurant where most of the workers Consider wages at a fast food restaurant where most of the workers earn the minimum wage. Would you expect the wages of all workers at this restaurant to have a normal distribution?
I put no because the normal, well, C says the normal distribution is symmetric, but no one earns less than minimum wage because that's the least amount they could get.
Yeah, that's a good response. Yeah, that's it. But like the other thing of that is like this curve, you would expect it, you know, if you have like a peak at minimum wage and then it's kind of going down, I would like say that's probably like a right skew, right? Was what that would probably look like.
Yeah.
Just like thinking beyond the question a little bit. Who's next? Sabrina? Sabrina around?
Yes. For what number?
5 and 6.
Okay, 5 and 6.
Yeah, and so 5 says in a normal distribution, about 2/3 of the data values fall within 1, 2, or 3 standard deviations of the mean. That's basically it.
Okay, 1 second. I'm looking at my book. I'm tabbing over.
2/3 is what, 66.6%?
Let's see. And then 2/3 of the data falls within 1 standard deviation.
Yeah, and it's going back to the 68, 95, 99.7 rule, right? And so if we get between 1 standard deviation, we get 68%. That's about 66.6. Yeah, close enough. That's what they're saying. And so that's 5. Part 6 says, suppose a car driven under different conditions gets a mean gas mileage of 40 miles per gallon with a standard deviation of 3 miles per gallon. If you drive this car many times, the gas mileage on 95% of the trips will be between, okay, and then they give us a set of numbers, 37 and 43, 34 and 46, or 31 and 49 miles per gallon.
34 and 46. So B.
6B. Yeah, that's it. And you're doing that because you're taking what? 2 standard deviations. So if 1 standard deviation is 3, if we do 2 of them, that's going to be what, 6?
Mm-hmm.
And so we're doing what, 40 minus 6, and then what, 40 plus 6?
Mm-hmm.
And so, again, maybe I should write it up here, but the rule is 68, 95, 99.7, right? 1 standard deviation, 2 standard deviations, 3 standard deviations, right? And so they asked about 95%, and so that's the 2 standard deviation one. Okay. That's it. Okay, so what, 7? Who was I on? Romeo? Was that the next one?
Yeah, number 7.
I don't know. Can y'all hear music in the background? Or is that? Okay, good. I was just wondering if y'all can hear it, because like people practice at this complex, so I can definitely hear it. There's someone like practicing some bass over there. It's pretty repetitive, but it's good. It's not transferring too much, but it is mildly distracting. Okay. Anyway, the joys of working at home, I guess, right? Number 7 and 8, I think, is what we're on. Consider again the car described in question 6 on about what percentage of the trips will the gas mileage be less than 37 miles per gallon. A is 16, B is 2.5, and C is 68%.
I'm gonna take a guess and say A.
And this is what, 7? Okay, so we're doing what? 37. And so if we go between 37 and 43, we're gonna get 68%. Yeah. I guess this is a good chart, probably maybe to draw. And I was gonna get to this eventually. I wasn't planning on doing this for this problem, but I guess I'll do it. So if we're doing 68% between those two values, if we look within those, within the middle, we're gonna get 34 on each half, on each side of the mean. That's not the right mean. And so if we look, if we have 68, if we subtract 100 from 68, we're gonna get 32. And so in each of these, we're getting half of that, which is 16. And so if we think about the 68 rule within one standard deviation, we can think about the middle is going to be divided up into like 34 and 34. And then if we think about the whole thing, it's got a total 100. So 100 minus 68 gives us 32. Each of these accounting for half of that. And so I'm hoping there's this sort of picture in your head when you're answering it. And so if they ask, what about it being less than, what number? 37. If they ask about it being less than 37, as you said, the correct answer is what? A, 16? And 8 is consider an exam with the normal distribution of scores with the mean of 75 and standard deviation of 6. If you get a 66 on the exam, what is your Z-score?
C.
Yeah, and a little bit, oh, I didn't do this one. I didn't do the calculation, but I'll do it right quick. So if we get a mean of 75 and you get a 66, first off, I'm hoping you realize that it's going to be negative. And so we're going to do 66 minus 75, and then we have to divide this by 6. And this is where they're getting, let me say C, the minus 1.5. Is that right? Is it exactly? I didn't do this one ahead of time. Yeah, it's exactly minus 1.5. That's it. And so that's calculating the Z-score. And so I think we kind of jumped into that. There we go. It's the value minus the mean divided by the standard deviation. Okay. That was number 8, number 9, and 10, Mr. Kelly.
Yeah, number 9 is C. If somebody tells you they're in the 102nd percentile, they don't understand percentile.
Yeah, that's it.
And yeah, I'm pretty sure I didn't get 10 right. I got C in that she's shorter than 69% of 7-year-olds.
Okay, so yeah, that's it. Okay. So an A, if they tell you they're in the 102nd percentile, that means 102 people. I guess you could say like part A, but that doesn't make any sense, right? I mean, technically that's what they're saying. They're saying there are 102% people underneath them, which does not make any sense, right? And so it's nonsense, so they don't understand what they're talking about. So 10, another way you can think of that is our max is going to be our 100th percentile, right? And we're not ever going over our max value. And so the height of a particular 7-year-old girl has a standard score of minus 0.5 among the heights of all 7-year-old girls. From the table 6.4, you know that. I have that table somewhere. So we're looking at a minus 0.5 in the table. Where am I at? Minus 0.5. There are 30.82. What does it say? Yeah, that makes sense. So minus 0.5. If we look at this, this is 30.85. If she is taller than 30.85, then what we want to do is subtract 100 from that. And if we subtract 100 minus 30.85, so 100 minus 30.85 should give you the, what, the 69, or it's close to 69. I guess I could do it. 100 minus 30.85, it will give us 69.15, right? That's where they're getting the 69% from. Meaning that 69% of the people are taller than her, right? Is the other way to say it, I guess. Okay. Any questions on these? I know there are multiple guests. I guess we could look at some of the other ones. This one would be that number we got from the table, right? If we wanted to make this statement, it wouldn't be that she's taller than 69. It would be that she's taller than that number we got from the table, which was 30 point something. The Z-score does not translate to like the inches, right? That's the other thing, I guess. Okay. I guess TJ ran away after I asked your questions.
Her laptop died. She just texted me that she's gonna come back in.
Yeah, she just came back in. Thought I might have scared her away. I don't think so. She came back. Okay, so what is that's 1 through 10. So that's all the quick quizzes. And so 15 is the next one. And so for these problems, for 15 and 18, they say state with an explanation whether you would expect the following data sets to be normally distributed. And so we're trying to figure if these are normally distributed. So the first thing they tell us is the weights of 200 new Ford F-250 pickup trucks. And then the next thing is the last digit of the social security number of 1,000 randomly selected people. And so who's next? Patrick, are you around? No Patricks? Narcy? Is Narcy around?
Yes, I'm here.
All right. You want to do 15 and 18? Talk about these right quick. And so 15, if we're talking about the weight of 200 like F-250 pickup trucks, would you expect that to be normally distributed?
I'd say yes.
Well, why would you say that?
I'm guessing that they would wait. Well, it just depends on how much they would all, I guess, weigh in total.
So we're talking about like the same truck, right? And you were talking about the same truck. You know, the same truck is going to probably, if we get one truck from the other, they're probably going to both weigh up what? About the same weight, right?
Yes.
And if you can say that, then you can say it's they're probably going to be normally distributed, right? And so I'm going to say yeah. And my reasoning is that there's a sort of like target weight that we're going for. And so most of your weight is going to be right around a certain number, right? There's a sort of target average weight that we can have for these trucks. And then you'll have a sort of like falling off, like you'll have fewer and fewer things that get as you get larger and larger, you'll have fewer and fewer of them as you get like smaller and smaller, right? But most of them are going to be around the same number. There's a sort of like target number that they're going for.
So what I'm misunderstanding about that is if they're all exactly the same, why is there any distribution whatsoever?
Because in reality, they will never be exactly the same. There's always variance in reality. So if you're like telling me this thing weighs like 2 tons or something, almost never if it's going to be exactly 2 tons, right? It would be like 1.9999999 tons or something crazy like that. It's never going to be exact, right?
Got it.
Yeah, and so we get a little bit of variance either way because we're not the neatest creatures. I don't know. Like it's our sloppiness is in there a little bit, right? I feel like the reality is not straightforward. It's a little messy, right? And real numbers are a little messy, basically. And so you get a little bit of variance. And so ideally, yeah, they would all be one weight. And that's kind of why we can say this is a normal distribution. And I'm probably giving you all that solution. But 18, on the other hand, if we talk about like 18, if we just randomly select social security numbers, would you expect that to be normal?
No.
Yeah, and I kind of led that a little bit probably, right?
Yeah.
Because like if we're looking at the last digit of someone's social security number, so it's either going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, one of the 10 digits, right? And if we're thinking about that, I don't really know. I might be wrong here. I would probably expect that thing to be about level. Like there's probably an equal probability that you will select any of those numbers, right? I don't know how, to be honest. This is kind of my educated guess. It's an even question, so not in the old book. It was a new question. So I'm kind of guessing. But like if I were to guess, probably not. Doesn't sound like something that would be. I would guess it would be about equal chance for getting them, so you'd have a level distribution, right?
So is that level because there are only 10 possibilities?
Yeah, and if you look at the possibilities and how many times they occur, right? If I were to do something like do all the digits down here, 0, 1, 2, 3, all the way to 9, right? I would expect each of these things, if I was doing a histogram, it would just be like a flat throughout the thing, right? There wouldn't be a peak anywhere there that I would know of. There's something a little weird, and I know it's probably going beyond this question, but there is a thing within like the natural numbers that exist out there. If you go and pick them, there is a weird thing that happens with the first digit. You actually get like, well, you can't have 0 with the first digit, but like 1, 2, and 3 comes up like way more than the other digits. So I know like if you're doing the first number, it looks something crazy like that, and it's got like a really crazy like down skew sort of thing happening there. And so I know that's definitely not normal. I can't remember exactly what it's called, but if you do the first digit probability, it probably comes up or something. There's a crazy rule out there that goes kind of beyond this question. Whew, don't give you all solutions. Okay. So 19, whew, this is an interesting one. 19, I want to do in 3 people. I think you can answer 3 at a time is fair enough. Is Patrick around again? I'm going to pick on him again until he comes back.
Yeah, I'm here.
All right. I want you to look at 19. I want you to look at A, B, and C.
Okay.
On part D, in E, I want to give that to Misty. Are you around? Okay.
Okay, yeah, I'm here, but hold on, I can't find my page. Okay.
All right.
That's
I'll
it.
come back to you in a minute. I'm just like letting you know what you're gonna have in a second. D and E.
D and E.
Yeah, 19 D and E is what I'm gonna look at. And then
Okay.
Lena, if you're around, I think you're probably here. If you want to look at F, G, and H, and I will lead y'all a little bit with this one. I will give y'all a little bit of information. Okay, let me grab some paper so I can cover up some answers. And so I'm hoping when y'all do problems like this, I mean, you can just crunch what they're telling you, but like to me, I wouldn't do that personally. And so this is one of the first things I did when I looked at this problem. I looked at this. I know my average is 100. So that goes right there in the middle. I know my standard deviation is 20. So if I want to do one standard deviation, I have to add and subtract 20. If I want to do two, I add and subtract 20 again to this, or I add and subtract 40 here, whatever way you want to think about it. Each one of these should go by 20. Each one of these should go by 20. And so I'm hoping this is the sort of picture you have in your head. And so there's a few things, if I can find that paper now. There's a few things I can do with this 68, 95, 98 rule. 95, 99.7, sorry, I said the wrong number. And so I can do this one earlier, but if I'm looking at 68 and I look at the middle, I know things are symmetric about the middle. And so I can do this sort of thing. I can divide that 68 into two parts. And so I'm hoping this is one of the first pictures you can come to. So in order to get the 34, we're dividing this thing up because we know this thing is symmetric. And so maybe I should like talk about this thing. Two sort of like facts I'm using to my advantage here, right? I know this thing is symmetric, so if it's happening on one side, it's happening on the other. The other thing is we're adding up to 100%, right? And so in order to get this 34 and 34, I'm using the fact that it's symmetric. This is the 68% going from here to here. It's 34 in each of these little quadrants, I guess I could tell them, right? There's 4 sections, it's a quadrant. Okay, so if I want to get the 16, what that's coming from is 100 minus 68, right? Will give me 32%. And so I know between this one and this one, I have 32%. So if both of these are 32% and they're symmetric, then I know each of these is 16%. And so that's my 60 rule. This is one standard deviation. $95 is 2 standard deviations. So I'm doing the same thing here. I'm taking the 95, I'm dividing it up. Each of those sides is going to give me like 47.5. This is 2 standard. So from 60 to 140, I'm going to get 95%. That's the 2 standard deviation rule. I divide this up into 2. I'm going to get this number, 47.5. I do 100 minus 95. That gives me 5%. So this one and this one together are going to be 5%. We divide 5 by 2, we're going to get 2.5. And the last one is the 3rd standard deviation. So we divide 99.7, we're going to get a crazy 49.85. So my numbers are getting a little bit uglier, but they're still there. 49.85, I subtract 1, I'm going to get 0.3. I divide 0.3 by 2, it's 0.15. And so between 40 and 160, I should be getting most of these things, right? And so I'm hoping when you answer these questions, like you have one of these sorts of pictures in your head. You could do the question just like using this sort of knowledge. You don't necessarily have to draw out this picture, but something along these lines should be in your head, right? Okay. And so if we go back to A, B, and C all use 80, 100, and 120. So this is probably the picture you want to use for A. A, B, C, okay. And so if I throw this thing up here, it will probably make A and B and C a lot easier. What's up, Kelly? Or Richard?
Yeah, so I'm just trying to clarify. With normal distribution, your mean is always going to be in the dead center.
Yes, because it's symmetric. And so your mean and your median are the same thing, and they're going to be dead center. Okay. Now, who did I say was A, B, and C? Patrick? Was that who it was?
Yeah.
Okay, so the first thing they say is greater than 100. So if we're looking at this,
Would it be A is 34%? I'm going along the right track here.
it says greater than 100. So 34% is part of
34.
it. What about this? Is this greater than 100?
Yeah, that's right. So that's added into it.
Yeah, so you got to do what? 34 plus 16?
50%.
Yeah. Oh, yeah. Well, yeah, I said that a lot harder than it is. If you're doing greater than 100, 100 is your mean. And so one of the easier way without even looking at this picture, right? If this is our mean, half is going to be here and half is going to be here, right?
Yeah.
So without even looking at the 68, without using the 68, you should be able to do part A. Yeah, you should really be able to do part A without even doing these rules. Just knowing that the mean is in the center and that we're going each side. Yeah, so A is 50%.
And then so B would be 16.
B is 16. They ask what is greater than 120. Yep, it's 16.
And then C is also 16.
And C is also less than 80 would be also 16. Yes, that's it. And there's a few different ways to do this. If you were to think about like, 120, maybe we didn't have this picture. If you don't have this picture, maybe think about how you might do this. So if you know 120 is one standard deviation away, you know one standard deviation is 68%. How did we get to 16? We did 100 minus 68 and we divided it by 2. My advice is to really draw the picture, to be honest. I think it'd really help you on something like this.
So I'm kind of confused with the very last. Didn't you have another picture you had pulled up?
Are you talking about there's 3 different standard deviations, right? We're doing 1, 2, and 3. The 68, 95, 99.7. There's also that other thing. Is this what you're talking about?
Yeah, there you go. So you're going down in increments of 20, right? And then you're going up.
Yep.
And so if I draw the same little picture, you know, I have the 34 in the first little column and then the 16 in the other one, and I have it on both sides. But that equals 100%. How, so this last little between 40 and 60, how do you calculate the rest of that percentage if you already have 100% between those middle four?
Oh, you're talking about?
Am I mixing two graphs together?
Yeah, I think you might be thinking about something a little crazy. I don't think we do anything that crazy in this class, to be honest. You can do it. You can absolutely do it. Are you talking about just like finding like an area maybe within here?
You're cutting out a little bit.
Are you talking about maybe finding the area like between two numbers, like 40 and 60?
Right.
You could do something like that because we're going between 95 and 99.7. They don't ask anything that hard in this class that I've seen. I might want to ask Mr. Martinez on that one. Is he around? Is he wrangling kids? Where is he?
Oh, hold on. Yeah, I'm also I'm trying to record the review. I'm trying to record the review at the same time here.
Okay.
In multitask. All right. What was the question?
Do they ever make us find anything between like two numbers like this, or will it always be like sort of like these basic sort of 68 shapes or whatever? Or these sort of shapes.
If it's gonna ask for like a percentage like between.
Yeah.
I mean, it should be at whole standard deviations.
Okay. Yeah,
It
that's
should
what I was
be at
thinking.
that. Yeah, the only time they use the like at a partial spot is when you get into that percentile, like doing that. But they're not gonna like take 2 percentiles and
subtract
figure
them.
out a difference.
Yeah.
They don't do that.
Okay. Yeah. I mean, if you wanted to, you could do it. The difference between divided by 2. It's the difference between those two intervals divided by 2 is the way I would do it. So it's doable, but it's not something we're doing in this class. Does that help?
I don't think the activity even had them go between like the 2 and the 3.
Yeah, I didn't see it.
Standard deviations. Like they did the 34. What's next to that? 13.5. Like the 2 in the middle are each 34. Then after that, like before, well, from 1 to 2 standard deviations, I think was 13.5.
Yeah.
I think that was as far as they went, and then they didn't get into that real tiny bit trying to divide that up. They didn't do that.
Okay. Okay, so what is that? 19, A, B, and C is what we've done. And the next one are D and E. D is less than 140. E is less than 60. So 60 and 140, I believe that was the 2 standard deviations. And what was it? How do I do this? What was it again? Less than 140, less than 60. Who's next? Who did I give these to? Was it Misty?
I had D and E. Is that
D
what-
and E. So D says above 140,
Uh-huh.
or it says under 140 is what it says. Sorry.
Okay, 97.5%.
Yeah, and there's a few ways to get that. We can do it. We can do 100 minus this 2.5,
Uh-huh.
or we could add these 3, right? Or 95 plus 2.5 will give you 97.5. Okay. And then the other one is what? Less than 60? And so less than 60 is giving
2.5.
Yeah, 2.5. Okay. And then later, I asked you to do what? F, G, and H. I made you do all these problems. First one is less than 120. Okay. Oh, I didn't mean to put those together. 80 and 120. Oh, they are. They're all the same graph, though, huh? So F says less than 120. She typing. Okay. Is Lena still here? Okay, there she is. Okay. It's 52. G. H is okay. So let's go over these. So F says less than 120. So if we want to do less than 120, what all does less than 120 pick up? We're gonna pick what? This up, or you could just say what? 68. So we're doing the 68, and we're also doing the 16. What is that gonna give me? 68 and 16 should be what? 84. Okay. And the same thing, we're looking at greater than 80. So if we're looking at less than 120, it's going to be 68 and 16. If we're looking at greater than 80, you might notice that's also going to be 68 and another 16. And so that should give you the same solution of 84%. And then H says what? Between 80 and 120. And so that's basically between one standard deviation. So how much is between one standard deviation? Yeah, there it is. And so the last one should be 68%. And hopefully, I'm hoping you got the 68. I'm hoping you understand where the 84 is coming in, right? Sorry. So the 84 is coming from, we have 68 and another 16. That's how much is more than 80. We have 68 and another 16 that's going to be less than this 120. All right, cool. Where am I at? 19. We did 19. Next one is 37. So 37 says, according to the data from the National Health Survey, the heights of all adult American women are normally distributed. And so they give a mean of 63.6 inches and a standard deviation of 2.5. Give the standard score an approximate percentile for a woman with each of the following heights. How bad are these? Okay. I guess we got to look up numbers and stuff. Lena's done. Jason, do you want to do 37A? Ian, you want to do 37B? Dina, are you go for 37C? And Brittany want to do 37D?
You said you want me to do A?
Yeah, just do 37A. And if y'all want to just do the Z-score, we can look at the table together. That might be beneficial. So the main thing I want is that Z-score. Did you get a good Z-score, Jason?
So yeah, that Z-score is going to be 1. It falls in that. It falls between the mean and that second that next line. Oh,
So how'd you calculate it, I guess is the question.
never mind. I did it based off the first one. Hang on.
Okay.
Okay, data value minus mean.
Okay. So to find the Z-score, it's data value minus mean, and then you divide by the standard deviation.
Yeah, I got it.
Yeah, someone asked.
Wait, so value minus mean divided by the standard deviation gives you the Z-score, not the percentile.
Yes.
And then
It gives you a Z number. You got to convert that Z number to a percentile.
Gotcha.
So 38.56 or 38.6.
For your Z-score?
Yeah.
It shouldn't be that big.
So if I do 64,
yeah,
minus 63.6 divided by 2.5.
Yep.
So 38.56.
Because 64 minus, did I do it wrong? Yeah, it shouldn't be that big. 64 minus 63.6 is what I'm doing, right? Divide by 2.5.
So, oh, hang on, I did it. God dang it. Oh, 0.16. I'm sorry.
Yeah.
I did it in a line and it screwed it up. I didn't get the answer from my. I just did 64 minus 63.6 divided by 2.5. I didn't do the.
I'm glad you did this because I was thinking about this while I was doing it. It does not give you the right answer, and I'm glad you did that because I know someone else out there is going to do it. I know it. I'm glad it got brought up. You got to be careful with the order of operations, right? And so when we see something, and when I see an equation like this, right, I'm going to know the answers. When I see an equation like that, you've got to kind of look at the top. When we divide stuff, you got to kind of look at it like, hey, we've got to do the subtraction before we do the division. And so your calculator doesn't know all this stuff with order of operations. So if you do that, what it actually did, and you can figure it out, it divided the 63 by 2.5, and then it subtracted is what happened, right? It did division before it did subtraction. Okay, so don't do that. But the solution's 0.16, and so if we're looking at 0.16, you might notice the table doesn't have it. So the closest thing to 0.16 is probably going to be, what, 0.15? And so we want the percentage. The percentile is right there, 0.15.
So would you go up to 56%?
I don't know what the book did. I think I just put the number on there, to be honest. You could probably say it's about 55.96. You could probably say about 56. If you gave me 56, I would be happy on it, personally.
So when looking at the D-score, or Z-score, excuse me, what do we do when it falls in between two of the given numbers?
You pick the one that's closest.
So for instance, it falls between 0.35 and 0.30, and you've got 0.325 or something.
Can you use the mean of those two numbers?
So you're saying between like 0.35 and 0.40? I mean, unless it's like 0.3725, it's not going to be directly in the middle of those two, right?
So if it's
you could probably like try to average those. I'm not personally trying to make this that complicated. Okay. I'm just trying to say pick the one that's closest, personally.
But I'm saying if it's like 0.48, right? So that falls between 0.45 and 0.50.
Yeah. I mean, the honest truth behind this is that the Z function and finding the area underneath there is kind of a super complicated thing. And we're not asking you to crunch it as a function. We're just giving you like a table and trying to ask you to like, hey, pick the closest value to it, basically. But to find area underneath curves, you actually need some Cal 2 sort of stuff happening. So definitely not going there with finding the area under curves.
No, thank you.
Yeah, that's what I figured. It's fun stuff, but probably not what y'all would enjoy doing at this level, right? So if that is A, who did I ask for B? Was it Ian?
I had the Z-score as -1 point.
-1 point. And so we go -1 point. Where am I at? That is what?
I picked the closest one was 15.87.
Yep, that's it. So I guess I can throw this up there a little bit. And then C,
I got -1.52.
negative 1.52. So that's going to be around what? Negative 1.5.
Mm-hmm. So the percentile is 6.68.
That's it. And the last one, last but not least, part D. Good, that one. Dean answered. Was Brittany next, or did I ask Brittany?
For D,
Yeah, did I ask you for D, or did I ask someone else?
I think so.
Okay.
I got for the Z-score 0.48.
Okay.
And
So we're looking at 0.48.
Around 68. 69.
Yeah, somewhere in there.
Yeah.
Yeah. Do you have any, like, Mr. Martinez? Do you have any word on like how accurate they need to be with this table? Just pick the value, because I told them just pick the value that's close enough. The closest value, basically.
Yeah, that's pretty much all you can do. Like any. So I was actually just recording that part of the review, and I wrapped it up there, and I was even saying that just pick whatever's the closest to it, because I think if you start trying to like split the difference, you're probably going to make a mistake at some point. At least I do. I make them left and right if I'm trying too hard to say, I bet it's a little bit closer to here, so let me like kind of trim a little bit off or add a little on. I would just take whatever's like the closest value. And as far as grading, what I usually do in that spot is I look at what the closest value is, and then I also acknowledge what's like right above and below it, just so I can make sure that it's within that range.
Yeah, I mean, in order to solve the actual percentile, like you really gonna have to use software.
Yeah, you like professionally speaking, you're not going to be using a table that fits on half of a page.
Yeah.
It's like, yeah, your Z-score should go beyond 1 decimal point, like when you do it, like, so.
Yeah, but I mean, we're not doing this by hand, is what I was also trying to allude to. It's not something you're like sitting there crunching by hand. You're going to throw this in some software to figure that out for you, basically. But I think there's this sort of like really interesting point. Yeah, it's time to talk about it, I guess. There's a really sort of interesting point. We talked about things. Well, we can talk about the standard normal curve, right? We can talk about the standard normal curve, and if I didn't crunch all these things up and throw them away, I can bring it back out. Then we talk about the standard normal curve, and we can do all this neat sort of stuff in it. We can do the 68, like 95, 99.7 rule. We know a lot of stuff about the standard normal, going 1 standard deviation. Where our standard deviation is 1. And so a lot of things aren't the standard normal. Like this thing was not standard normal, but there's like some tweaking we can do to make it look like standard normal. And the tweaking we did to make it look like standard normal was, where's that? Is this sort of thing. We're going to subtract the mean and we're going to divide by the standard deviation. And so this is going to give us a score on the standard normal. And so I don't know how to explain it, but we use the standard normal sort of like it's a unit in statistics. It's like we don't know what like a lot of other things are. Like we don't know what this really looks like, but we can compare it to the standard normal and then we can get information about it, right? We don't know what a lot of sort of populations look like, but there's ways we can tweak them and like move them around. And ooh, I'm giving you answers for further stuff. Okay, we can tweak them and move them around, and we use like the standard normal to sort of get a grasp on other things. And so throughout statistics, a lot of it's just sort of comparing things back to the standard normal curve, back to those sort of things that we know about the 68, 95, 99.7. We really use the information we know about the standard normal to like project things onto other things that we don't know so much about. If that gives you any kind of insight into like what statisticians do. That's good. I don't know. Maybe so, maybe not. Who knows? Okay. And so maybe you noticed it, but like this thing, it's centered at 0, right? And so the standard normal has a mean of 0 and it has a standard deviation of 1. And so if we go from like -1 to +1, if we subtract 84.13 from 15.87, I bet you that gives you that 68% from 1 to -1. I bet you that will give you 68%. And so the standard normal is something with the mean of 0 and a standard deviation of 1. And you probably already explained that in the video, but
maybe.
Re-emphasis does not hurt. Yeah. Okay. Is it likely? Suppose you read that the average height of a class of 45 eighth graders is 55 inches with a standard deviation of 40 inches. Is it likely? Who hasn't answered something? Andrea, are you around?
Yeah, I'm here.
Okay, so suppose your average is 55 inches and the standard deviation is 40 inches. Is that likely?
No.
What I would do, I would think about the ranges of those numbers that they're gonna encompass, right? 1 standard deviation, 2 standard deviations.
No, it's not likely.
Yeah. Why is it not likely? Well, if we do 2 standard deviations, if it's going, what, 40 is 1 standard deviation? If we do 2 standard deviations, if we add and subtract 80 to that, what's happening to those numbers? That's what I was thinking about.
Yeah.
We're going from, what, -25 inches to 135 inches, just with 2 standard deviations, right? This is supposed to be, again, I can't, 95% in there, right? From -25 to 135, that's supposed to be 95% here. And so you might notice this is what? That's a negative number, so that definitely doesn't make any sense. This is going to be 11 feet. I don't think any of these little kids are going to be 11 feet tall. Yeah, it doesn't make a whole lot of sense. Not very likely, right?
No.
Yeah, okay.
Whew. It is.
I'm giving you all answers away already. Okay. 41, who else is around here? Who did I just call on? That was Anaisa?
I was hoping you wouldn't call me for this one because I've been trying to work it out and I am not getting the right answer, I don't think.
Okay, for the verbal, how about we do one of them and you can do the other. That sounds like fair.
All right.
So if we do the 90% Z-score, it's about 1.3 from our table. I think I figured out exact. If you want to know exact, it's 1.282, whatever. It's about 1.83.
Yeah.
And so we need to go 1.3 standard deviations on each side, or actually on the positive side, I believe, right? This is plus 1.3. So we need to go 1.3 standard deviations above this thing. And so if I want to think about 1.3 standard deviations, my deviation was 8.5. I'm going to go 1.3 of those.
Yeah.
And so I'm going 1.3 above my average, which was 150.
Uh-huh.
And so it should look something like that. You should have your average plus 1.3 represents the 90 percentile, and this is your standard deviation.
Okay.
And so I think I'm getting 161 and like some change. And so I think in the book they just said the 161st percent, or yeah, 161 is a score. Sorry, it's not percentile.
Right. So then let me try working out the second part.
Okay.
Which number are we on again? 43?
Yeah, 41.
Okay. So 152. I got 163.05.
No, it should be a little bit higher than that. Did you do the 152 plus the 1.3 times? Did you change that one to 8.9?
Oh no, I didn't change it. Okay, because I didn't realize.
Yeah, it's different. They give you two different means and two different standard deviations.
Okay, so then it would be 150 plus 150.
You were close.
161.57.
It should be like 163.5, right? Somewhere there.
I got the same answer she did.
Did I do it wrong?
Oh, okay. I see what I did wrong. It's because I did 150 plus 1.3 times 8.9.
Oh yeah.
Okay, yeah, 163.57.
Yeah, that's it. And then if they're gonna round that to about like what, 164?
164.
So score 164 will get you in the 90th percentile.
Okay. I think I was confused because they gave the percentile. It kind of threw me off.
Yeah, I'm not. Oh man. Now I'm forgetting what you had in your notes. This is very similar to the thing that we were doing before, right? Maybe you can notice it. But if I want to know the score here, and like I was doing some back solving, and like this was my unknown, right? And I want to know what score for a certain percentage, I would have to first multiply the standard deviation and then add the mean, right? It looks very similar here. We get a z-score times our standard deviation, and then we have to add the mean, right? And so this really is kind of that previous equation we had. It's just moved around a little bit to find the score that you need, right? Did they give you this formula? I thought y'all had this in your notes, but I could be wrong.
Yeah, it's in the notes.
Okay. So that's 41. So 41 through 47, you're using these facts. About the GRE, the verbal has a mean of 150, deviation of 8.5. Quantitative has a 152 with a deviation of 8.9. And so we're still using those two facts. We're doing 43, 45. What else did I not pick on? Alondra? 43 says, what percentage of students taking the quantitative exam scored below 160? Sorry, above 160. So if we want to know, I don't know how to tell you this, but I would almost never like solve for anything above. I would solve for the below, and then I would do the 100% minus. And so typically if they ask you above, kind of ignore the fact that they're asking for above and solve for below first. And so if I wanted to solve for below 160, how would I solve for below, what is below 160? And I'm hoping, I'm going to flash this up here. I'm hoping that your solution or your approach looks something like this. Have I picked on Alondra yet today? Trying to figure who I've picked on or not. Is she here?
Are you saying pick to on like you're a bully?
Yeah, I'm still a bully.
That's good.
I think she's not away. I think we'll just go through these last two. I think I picked on everyone. All right. So if I want to figure out what is below 160, my approach to figuring out what is below 160 is I'm going to take 160, I'm going to subtract the mean, I'm going to divide by the standard deviation. And so this, I believe, is coming from what? The quantitative part. So make sure you're using the right exam. You're using quantitative. So the quantitative had 152 mean and it had an 8.9 standard deviation. So if I do this number crunching, I believe I'm getting 0.90. Now, I have 0.90. I probably rounded that. I think it's like 0.89 and some change. And I think it rounds up to 0.90. So you might have to do some appropriate rounding. But if we look at our table for what, 0.9, I believe that's giving me what, 81.59. So if 81.59 is below 160, someone tell me what is above 160.
You just subtract from 100, you get 18.41.
That's exactly what you get. So this goes back to that we know things are symmetric. I guess I could draw like a quick picture. We know things are symmetric. We know things add to 100, right? And so if I know that this thing over on this side is 81.59, I know this thing has to be 100 minus that, right? So 100 minus 81.59 should give you that 18.41% that's there. Okay. And so as a reminder, the z-scores give you everything less to the left side, right? And so the z-scores are giving you the area of everything to the left. And so we're getting the area of everything less than 160 is going to be this. We're getting this from the table. This is coming straight from the table from that 0.9. We get this. We still need to subtract 100 from this thing to get the right side of it. Any questions on this thing? Okay. So what does 45 say? Find the percentile of 150 on the quantitative exam. Okay. So I feel like maybe they asked these out of order. I feel like this one might be a little bit easier. But if we want to figure out the percentile of what, 150, well, if we want to know what is below 150, We subtract the mean, we divide by the standard deviation. And if we subtract the mean and divide by the standard deviation, you could probably tell right away, since we're below our mean, this thing is going to be negative. So you might notice that. If we go below the mean, our z-score should be negative. If we're going above the mean, our z-score should be positive. That's what happens when you center things around 0. And if we go look at minus 0.22 in our table, I think that's probably closest to minus 0.20. So this says somewhere around 42.07. And I think they rounded it to the 42nd percentile. Okay. Should we do a race for the last one? All right. So I want y'all to think about the last one. I want y'all to set it up. This is an open question, 15 part B. Anybody that wants to answer it can answer it. First, give me your z-score. Or tell me what you did. How about that? Tell me how you got your z-score.
Is it 157 minus 150 divided by 8.5?
That's it.
It's 0.82.
That's it. And can you get it from the table? I don't have that table on me. Should I flash the table up here? 0.82. So what should that be? So what percentage is that? I think I probably saw it right. Hoping 78.81. Right at like 0.82 would be somewhere in between like what 0.80 and 0.85. Probably closer, like a little bit closer to that one. I think probably they would say like probably the 79th percentile, right? You probably guess about the 79th. So what words of advice do I have with this? Practice. Practice finding that z-score. Practice looking at that z-score on the table. Math is a pretty thing to look at, but it don't help you learn it a whole lot. You got to go out there and do it a little bit. How to calculate which one? I missed that.
I think that was the question about doing V minus M over standard deviation.
Any questions?
Can you tell us again which sections are on the test?
Everything up to here.
What did it start with? I think we did 5A, 5C, 5D. No. How many do we do in 5? I know there's 6A, B, and C. I know 5A, we skipped 5B. 5C and 5E.
I think it was 3.
Did we do D?
I know that's all on Blackboard, and the notes are separated by unit, so you can look at that. All the notes come up under Unit 3.
If you give me just a second, I'll go get my folder. I got it. It'll take like 20 seconds.
I guess my other question is, do we have 2 more tests after this, or we only have 1 more test?
There should be 2 more tests.
Okay.
Just test and then another one.
Did you guys already answer it? Like what's on this test?
It was 5E, right?
Yeah, it's going to be 5A, 5C, 5E. Then we have 6 ABC.
Last question, will you do a review before the final test?
Yeah, we'll have a review for that. Everything's going to be the same. So technically I don't know how we'll like open up the window for the testing, but like the last day of class isn't going to be a lesson. That would be like a test day. The test might be available a little bit longer, but we're not going to have a lesson on that day. So you will get a review. I guess the last day of class is a Wednesday, so I don't know if I can make any promises on what day you'll get the review, but there'll be a review and there'll be a video. I want to say the last section is not like super challenging, but it looks like it is. What it all like kind of filters down to is you've got different formulas that you have to use. A couple of the formulas are really like big looking. Like once you watch the video, hopefully you'll figure out that like using them really isn't that bad, but like if you can get past the fact that you've got these large looking formulas, they're very repetitive in the problems that we do. So once you get the hang of it, it does get fairly easy with most of it. 4E might be the hardest part, which is the very last one we'll do, which is going to be income tax, because that has a lot of little pieces to it.
Okay. Question? Am I echoing back at myself? Is that what I heard?
I made a noise. I don't know.
Okay.
I made a noise and it's just like a clicking sound. Like, I don't know. The one example I've always liked about normal distributions, like today's content, was SAT scores, which I don't know if you want to do an example of that. I'll give you my SAT scores and we could do a calculation if anybody wants. But when I was in high school and we took the test, I think like most high school kids, you look at scores as linear data. Like if I did 10 points better than my friend and then like some other person did 10 points better than me, that we almost think like that person who did better than me, like, I don't know, like the comparison in the score, like they must have answered so many more questions right versus how I did in thoughts there. But we think of it as like linear data. Like if there's an increase of 10 points, you think almost like a 10-point increase represents like 1 or 2 more questions, and it's consistent, but it really isn't actually done that way. So I suck at like the verbal test. I can't read and write if my life depends on it. I don't know what's wrong with me. It took forever for my parents to accept the fact that I just wasn't good at English class. I was a C student forever. But my math I was always like proud of. That was like my thing. So when I took the SAT for the math, I wanted to get to like a 750 out of 800. Like I wanted to have a really high score. I ended up with a 690, which I was disappointed in because I was like, man, I didn't even get into the 700s. I should have done a lot better than that. However, years later, figuring out that SATs are scored as a normal distribution where the mean is at 500 and the standard deviation is typically 100. Like when I went back and calculated what my score represented, my percentile was actually really good. I was like, oh, that's crazy. I've been mad at myself or disappointed in myself for like the longest time because I thought like I really screwed up the test, but I actually did pretty darn good on it. And then it was funny to look at my verbal score because it was a 540. It's not even close. Like when you look at percentiles. I don't know, Sievers, you want to calculate them? Yeah, we can make it quick. Let's. Can you draw like a basic distribution graph?
Can I ask a quick question?
Yeah.
Hey, on our grades on Blackboard, is final average, is that our grades, is that our homework and our test together? Is that just our test?
Yeah, that's what I put together so you could see it all together at one spot. Now I'm going to say here, Seaver should probably double check like how I set that up because I'm not really like great with Blackboard. I usually would record grades in my math lab for my other classes. So you might want to double check a little bit, but like I think I got it right. I think I got it all averaging correctly. There's a couple of people I was looking at their grades to see if it made sense when I did it, like checking their different test grades and their daily grades, and it seemed to look correct.
Our assignments only 20% and tests are 80%.
Yeah, that's how I said it was 20% and 80%.
Okay.
Yeah, but I'd still have them double check my work just to make sure I did it right. Because I was also kind of like half out of it, man. I think it's like something about the weather's messing me up lately. Maybe it's the I never like have allergies, but Maybe there's something else in the air, other than coronavirus, of course. All right, so Sievers, he drew a normal distribution in the middle for SATs. That should be at about 500. Let's have them add that in. Now, when they actually get the data back, it doesn't end up being, exactly 500. It can actually end up being like maybe 510, or it could be like 4 something if it was, I guess, a harder test. But they usually design the test so that the average score is going to be a 500, which if you go in like you're applying at colleges, and many of you probably looked at that stuff recently, most colleges are going to want you to have a minimum of a 500 in each test, because that represents that you're at least at the 50% mark with everybody else. So I found that interesting too. All right, your standard deviations are going to increase by 100 each direction. Oh, you can add those in if you want.
I didn't know where we're going with this.
Oh, okay. All right. So go ahead and add your standard deviation. You got 600. You got 700. Then you got 800. Now, here's a cool little thing that you might, know that the SATs, you can't get over an 800 per section, right? And 3 standard deviations is going to get you to 800. So what lies on the outside of that is only 0.3% per side. So it basically covers the whole graph with that. All right, so let's do a sample with my math score. My math score was at 690. You can put a little X there or something. Yeah, about right there. So, okay, so I was in that spot. Now, that was a score that I was, because the way I thought about data originally, I was disappointed, because I thought that at 690 out of 800, proportionally, that means I must have missed a lot of questions. Like, how did I lose over 100 points out of 800 points? I must have missed a ton of questions. Okay, but if we calculate my percentile, we're going to take 690, subtract the 500, then divide that by 100. You can write that up?
Oh, wait, 690 you said?
Yeah, 690.
Against the track.
And that's a true score. I'm actually proud of it now. It's a true score. I only took the official SAT once, and I took it the day after I went to go see 311 in concert. Yeah. I got home super late because I was parked at the top of the parking garage. This was at Austin Music Hall back in the day. All right, so my Z-score is 1.9. All right, go look at that on the table. And then all of you guys, you can do this stuff with your SATs if you want. I think it's kind of interesting to see like what it turns out to be. All right, so I see it. Does everybody else see it? All right, so other than Sievers, what does that tell us? Because he knows what it means. What does that number tell us?
That you scored as high as 97%. No, you scored as high as 3% of the rest of the population.
Yeah. Say it again. You might want to rephrase it, but say it again.
That you scored in the top 3% of math.
Yeah.
Scores.
Yeah, for everybody who took that version of the test that all this data got collected from, I was in the top 3%. But maybe better stated, I did better than 97% of everybody else who took the test. It's pretty good, right? So anyway, for like a year, like until I took stats, for a year, I was like, man, I must have missed like 10 questions on that test to to get as low as a 690 because that's 110 points I lost. But the way that the distributions are designed, the data is really thick in the middle and then it spreads out towards the end, right? So once you get past like 1 standard deviation, those little bits of changes in the score are like a lot as far as the percentile. All right, and then if you guys want to get a good laugh out of it, so that's my math score, right? It looks pretty impressive. My verbal score was a 540. I barely got enough to even get into college with my verbal score. All right, so 540 is going to give you a, when you subtract, you're going to get 0.4. At least it's a positive 0.4, but you're going to get a 0.4 for the z-score. Right, yeah, subtracting 500 divided by 100 is, no, yeah, it wasn't that good. It was only 40 divided by 100, so 0.4. All right, we go look at that on the table. All right, you guys see it?
Still above the curve a little bit.
Thanks for patronizing me.
It's, I mean,
It's not much, it's 65.
well, I mean, that's actually kind of interesting because I don't think we've used that term yet. Like, there's that term that people always use above the curve. This is kind of like what they're talking about.
Yeah, that's true. You get to work that one in there. So I did do above the curve. I was on the top half of it, but I was only at 65 percentile. Yeah, good. Brittany gets it. It tells the exact story of who I am as a student ever since I was a kid. I mean, my parents, they put me in, the GT classes and all that business, but and my dad was military, so he would get like super pissed about me coming back with like a 72 in my English classes. I also got really low grades in my my social studies, but in those courses you had to do a lot of reading as well. So yeah, so even though like I'm good at math, and I was thinking about this as a teacher, even though I'm good at math, the one thing that I always like to share with people is that like I can relate when stuff is challenging, when you don't get it, because to today, I still don't know how to like read a chapter of a book and answer questions about it. It just, my brain doesn't function that way. And I really wish I had a teacher that could have figured it out and then helped me to do better, but yeah. My GRE scores are even, no, all right, my GRE scores, I can't remember those exactly, but I remember my verbal for that one. You take the GRE to go back to graduate school. That's what it's for, to get a master's degree. So my math was like way up there again. It was like 94 percentile. But it should be because I teach math. At that point, I've been teaching math for like 4 years, so I was really good at it by then. But my verbal score was, I forget how low it really was. Like it was below the curve, to the point that I made sure that when I was applying for what I wanted to do in college, master's degree, I was like, look, I want you to understand, we all know that reading and writing has nothing to do with what I'm trying to get my degree in. So.
Oh man, I have a story about my GRE. I don't remember exactly what I made on it, but I know I did not do good on the writing portion because I was like finishing it up. I was like one of those cases. I was like finishing it up and I was like right there. And then I look down at the time and it's like 0.1 or 1 second left. And I'm like, oh no.
Okay, so
it's a good essay, but like at the end there's a sentence fragment. So then they totally just like give you like, crud points for it. It's
it
like
just cuts off on you.
Yeah.
All right. One more thing about that. When you took, because they changed the GRE test at some point, because I took it twice for different things, and the first time I took it, when you do it on computer, you can't go back and answer questions. Like you just have to move forward. So if you can't answer a question, you just had to guess and like cross your fingers you got it right. Was it like that when you took it, or was it where you could go back and forth between problems?
I think you could go back and forth when I took it.
Okay. Yeah, so the first time I took it, man, it was intense. Like when you do like this, this for everybody to listen to here. When you do an individual section, just say you're doing a math section, I think it had 22 questions, and you had to do it in 30 minutes. And you would press a button when you were ready to start. Now you had to start by a certain point, but you could start sort of when you wanted. And you just say, "You ready to go?" And you say, "Yeah." Hit start. And the first thing you see before you even read your own question, it's there. There's a question in front of you. Before you even read it, your eyes go to the top corner because there's a little clock that says 30 minutes, and it immediately switches to 29:59, 29:58, and you just go like, "Oh shit, I gotta get working here." And it's one of the most intense tests I've ever taken. You're just watching that clock tick.
Are there any more questions about the work, or should I like stop the recording on this?
No,
one?
I'm all done. I'm all done with that part.
Okay, I was just making sure.
Can we do questions on the homework?
Yeah, sure. Which one?
Just the 6C, the one we're turning in.
Oh, that one.
The graded one. I just don't feel like I'm doing it right. And I'm having trouble mostly with section E and finding the temperature for the 20th percentile. I don't know how to find that. And I know we touched on it, but I've been rather confused throughout this entire section.
So percentile.
It's here. I'll throw this out and then I'll let you work it because you got the camera. But I think it's like it's a 4-step process. All right. If you have the percentage, go look up the z-score. That's step 1. Figure out what the z-score is. Step 2, multiply the z-score by the standard deviation. Step 3, you're going to add or subtract. It should just be add, but you're going to add or subtract from the mean. So maybe that's only 3 steps. Use the percentage to get the z-score, multiply that value by the standard deviation, then add or subtract that number to the mean.
So I believe the z-score for that is like right here, right? Negative 0.5845. How about I do the 30th percentile? That's in your work.
That would be some work.
So, like on this one, if I'm doing it right, so it asks for the 20th percentile, and it shows 19.77 and 21. So, do we just go between a z-score of negative 0.85 and negative 0.80?
I would just pick one or the other, to be honest. I think I just picked this one, negative 0.85. I think is that closer? I'm not sure.
Twentieth percentile. Okay.
I'll do the 30th percentile. So we were to do the 30th percentile. We know it's a mean of 98.25. We know a standard deviation of 0.73. So I'm taking the mean, and I'm adding the z-score times the deviation, 0.73. I'm running out of room here. So the z-score for the 30th percentile, I'm getting that from the table. That's going to be negative 0.5. If I have a standard deviation of 98.25, or sorry, if I have a mean of 98.25, standard deviation of 0.7, shoot, I missed the thing again. 0.73.
I'm sorry, why is the z-score negative 0.5? I thought it was negative 0.85.
No, he's doing.
I'm doing the 30th. I'm not doing the 20th. I'm going to change it around a little bit.
Okay, I'm following you.
And so I want to figure out what this thing is.
Minus the mean. Okay. And minus the mean is 98.25. 8.25. Okay, so let me see. Let's see. Okay, 85 minus.
So that gives you 87.885.
Mm-hmm. Yep.
And so we'll just do the same thing with 20%.
Yep. And so instead of 0.5, you're going to be plugging in
negative 0.85.
Yeah, that's it.
All right.
Okay, hold on. 98. Okay. Where did the 0.73 come from? Hold on.
Standard deviation.
Oh, okay. Oh, okay. I see. I see. I don't know what that is.
So I've got to multiply the standard deviation by the z-score. Z-score is telling me like how many standard deviations, and it also kind of tells me what direction it's going in, right? But we should also know if it's below 50%, we're going to get a negative z-score, right? If we're centered about 0, standard normal is centered about 0, and it goes 1, 2, 3, right? -1, -2, -3. Sorry, I got this drawn like horribly not symmetric or whatever the heck, but it's there. Pretend like that's normal.
Is 0.85.
That's the way our standard normal looks, right? It's centered at 0. And so like if they give you a percentile and we know it's less than 50%, because we know this accounts for 50%, we also know the z-score has got to be negative, right?
Deviation is.
I think I'm going to stop the recording unless there's any more questions about this material.